You are listening to The Vocal Technologist. Spoken tech for your ears.
You know, it feels like we've hit this point, this new stage of tech, where the second you finally get comfortable with the data stack, like you finally nailed your ETL, your dashboards actually look good, the entire landscape just dissolves. It just reforms into something completely new. It really feels like we're all running on this technological treadmill that's just sent way too fast. Welcome back, everyone. Today we're digging into some really fascinating material that I think captures a consensus that's building across the industry, which is that AI agents, they're not just another cool layer on top of our data architecture, they're actually forcing a complete overhaul of the entire stack. I mean, everything from data modeling all the way down to how the databases actually work. So our mission today is pretty straightforward. We want to explore this massive architectural shift. We're going to look at how data teams are seeing their jobs just fundamentally change, moving away from building static artifacts and more towards curating the context and the logic that these machine systems need to operate on their own.
It's a huge shift. I mean, it's really the difference between being a cartographer and being, say, a civil engineer.
Oh, I like that analogy.
Yeah, you're not just drawing a beautiful map of the territory anymore. You're actually building the automated vehicle that drives itself across it and, delivers things. The focus is so much less on a beautiful report and much more on engineering an environment where these intelligent systems can deliver trusted answers and actions instantly.
Okay, let's unpack that, starting at what feels like the beginning of the end for the old way, the death of the dashboard. For years, the dashboard was king. It was the whole promise of self-service analytics. But the material we've been looking at says pretty clearly that dashboards were never the destination. They were just a workaround because our tools just weren't smart enough. So why is this feeling of a dashboard dead end so pervasive right now?
Well, I think it boils down to a pretty fundamental realization. Visibility is not analysis. Dashboards are great at showing you what happened, a historical snapshot. But they can't reason. They can't investigate, and they definitely can't answer a new question that wasn't already pre-baked into the filters.
Right. You get the high-level numbers, but the second someone, the CEO or an analyst asks, why did this number spike? Or what cohort is driving that change? You're back to square one. You're raising a ticket with the data team to go drill down.
Exactly.
The whole self-service movement just kind of hit a wall because static charts can't answer the next question.
Precisely. And this is the core of what's different about the agentic shift. An agent is an active system. It's designed to investigate and to act. So the data team's job changes completely. They're not visualization designers anymore. Now they have to focus intensely on curating the context, the metadata, the business rules, all the logic that lets these agentic systems deliver direct, reliable answers right from the warehouse. You're feeding a machine that thinks, not a human who just looks at a chart.
And this demand for instant autonomous action, it's creating architectural requirements that honestly sound a little bit like science fiction. The material points to something called hyper-tenancy. That sounds less like a database and more like a massive computing grid.
It is intense, and it's the new axis for database scalability. Traditional multi-tenancy, it's about serving thousands of users from one shared database pool. But AI agents have a completely different need. We are talking about the ability to spawn and manage maybe trillions of isolated ephemeral database instances.
It's trillions. Hold on. Why would an agent need its own database instance? Why not just query the main warehouse?
Because every single agent needs a private, isolated, and super fast environment for each specific task. So think of it like this. An agent needs to calculate a personalized risk score for one customer using a specific set of features. It needs a private sandbox with really strict data isolation. That instance might only exist for milliseconds.
Oh, I see.
So when you scale that up to millions of agents running in parallel, you need microsecond provisioning and then instant teardown.
That's a huge architectural shift away from that traditional, monolithic multi-tenancy.
Absolutely. That is the core of hyper-tenancy. And it means we need a fundamental move towards specialized, lightweight, in-process databases. Things like SquidLite, Terso, DuckDB, these can be instantiated instantly, and they're becoming vector native. The whole paradigm is changing because the agents demand it.
Okay, but this brings up a huge point of trust. If an agent is spinning up its own little world and generating its own logic, how do we possibly trust it? Is there a good example of an agent that acts more like a responsible human analyst and less like a one-shot SQL guesser?
Yeah, MotherDuck's new answering machine tool is a fantastic case study for this. It doesn't just try to guess one SQL query from a sentence, which that's where you get that 30% accuracy problem we can talk about later.
Mhm.
Instead, it has this agentic approach that's meant to mimic how a person would work. It doesn't just spit out a query. It explores the tables, it looks at the metadata, it runs an initial query, then it checks the results to see if they make sense, and then it iterates, sometimes running several more queries, until it has a verified, reliable answer to that plain English question.
So it's not just giving you the answer, it's showing its work. It's providing the methodology, which is exactly what we trust human analysts to do.
Exactly. And that's what might actually bring self-service analytics into the realm of reliability, even with messy enterprise data.
Okay, now this is where it gets really interesting for me. We've covered what agents do, but we have to talk about the plumbing underneath. Agents are relying so heavily on vector processing, and that means our core relational databases are changing faster than ever. So let's get into the technical shift, specifically vectorizing things that aren't text, like SQL queries.
Right. This is a subtle change, but it's incredibly powerful for internal efficiency. The technique is basically to transform the actual SQL queries themselves into vector embeddings, using models that are trained to understand the semantic meaning of code.
But why? Why bother vectorizing SQL? It seems like a lot of work. Why does using something like cosine similarity to measure how similar two queries are? Why does that matter to a data engineer?
It matters a lot because it lets you quantify your query workload. When you can cluster and visualize similar queries, you get this amazing visibility into what users are doing, what the common access patterns are. It just takes the guesswork out of optimization.
Oh, so you can see if like 100 different analysts are all basically asking the same 5 questions, but just with slightly different syntax?
Precisely. And then you can get smart about caching or indexing or just managing costs. It's like fingerprinting your entire query ecosystem.
That makes a ton of sense.
Yeah. And speaking of technical breakthroughs that just change the economics of everything,
Mhm.
let's talk about PostgreSQL. For a while, it seemed like standalone vector databases had this huge technical moat, right? You needed dedicated infrastructure.
Yeah.
But that moat, it seems to be evaporating pretty quickly.
It really does. I mean, we're seeing this huge breakthrough in Postgres vector indexing with this new method called VectorChord. Previously, if you used PG vector to index, say, 100 million vectors, a pretty common scale for enterprise LLM maps, you might be looking at 40 hours of compute time and 200 gigs of memory.
Yeah, and that cost 40 hours and 200 gigabytes. That's a massive barrier. Just stops smaller teams from even trying.
Right. But VectorChord cut that build time down to about 20 minutes,
20 minutes.
using only 12 gigabytes of memory. It's not a small improvement. It's a total order of magnitude shift.
And the gains come from this combination of hierarchical k-means clustering and dimensionality reduction, plus some really deep optimizations in how Postgres handles parallelism.
So the why we should care isn't just about speed, it's about democratization. It means smaller companies can now get robust, billion-scale vector search right inside their existing database without needing a massive GPU investment.
That's exactly right. It makes the good old general-purpose ACD compliant database a lot more formidable in the vector world. It really puts the pressure on some of those single-purpose vector databases.
Okay, but even with all these amazing infrastructure leaps, we have to keep the whole LLM to SQL thing in check. You mentioned the one-shot guesser problem before. The material we have paints a pretty grim picture of how LLMs are actually doing on real-world data.
It does. I mean, LLMs perform great on these clean public SQL benchmarks you see online, but the reality is that their accuracy is near zero on real, messy enterprise warehouses. It's only about 30%, even if you're using retrieval augmented generation, or RG.
Only 30% accuracy, even with RAG, on a complex enterprise schema that feels like the hype around just asking the LLM to write the query is still mostly smoke and mirrors for anything critical.
Well, companies are hoping to solve that easy 30%, the simple reporting stuff. But the low accuracy on anything complex just underscores this crucial point. Just generating a query is not enough. If an agent is going to execute a critical operation like changing inventory or approving a loan, the entire stack has to move toward durable, AC-compliant agentic systems, not just simple query generators.
Which is a perfect transition to reliability. If agents are driving the business, the systems have to be bulletproof. Let's talk data quality first. The material flagged a very specific, and I quote, undiscussed source of leakage in common models like XGBoost and LightGBM. Can you break that down for us?
Absolutely. This is a subtle one, and it's all about how these models handle high cardinality categorical features. So think about things like product SKUs, unique user IDs, that sort of thing. When they encode these features, they can sometimes accidentally memorize the target variable that's tied to very rare categories. It's a form of data leakage, basically during training, that makes a model look amazing in tests, but then it fails to generalize in the real world. The model is essentially cheating.
So it stops the model from cheating by looking too closely at those rare, unique categories and forces it to see the bigger picture.
That's a great way to put it. And the fix comes from an alternative model, CatBoost, which uses what are called ordered target statistics. It's a mathematical trick that just inherently prevents that memorization. And as a huge bonus for ML teams, CatBoost also auto-generates feature interactions, which saves a ton of manual work.
Okay, so that handles data quality. But what about operational reliability? When agents are managing the cloud, we need durability. The Netflix example here is it's staggering. They moved their Spinnaker cloud operations to a durable execution platform called Temporal. What happened?
The result was, it was truly phenomenal. These transient cloud deployment failures,
Yeah.
The little errors that require a person to go in and restart them.
Ones that drive everyone crazy.
Exactly. They dropped from 4% all the way down to an almost unbelievable 0.00001%.
A 4.5 orders of magnitude improvement, that kind of reduction in failure just completely changes how a team works. It means the ops team is spending 99% less time firefighting.
Exactly. And they did it by making their core system stateless and enforcing idempotent API calls through Temporal's workflow engine. Idempotent just means you can safely retry any operation because the result will be the same. The system can literally heal itself.
Which highlights this massive trend. Durable execution platforms are becoming essential for any kind of reliable agent-driven operation. You can't have an agent fail halfway through a complex task and just start over.
The ability to pick up exactly where you left off is non-negotiable now.
And on top of that, governance has to be adaptive. Static rulebooks and, quarterly audits just won't work when systems are changing this fast.
No way. We need adaptive AI governance frameworks. They have to integrate continuous oversight, dynamic policy versioning, and automated monitoring right into the CI/CD pipeline. Governance can't be a separate team anymore. It has to be part of the engineering process itself.
And I guess that means privacy engineering goes from being nice to have to a core design constraint.
Absolutely. That shift is driving the need for things like differential privacy, secure enclaves, and synthetic data across the board. You just can't bolt on privacy and governance later anymore. Shifting gears a little, let's think about platform strategy. How should companies structure their whole data platform for this agentic future? It seems like we're seeing a contrast emerge. Do you build a flexible, open, composable stack, or do you go for a unified, more opinionated data platform?
That feels like the classic builder's dilemma, just amplified by the speed of AI. What's the thinking on that?
Well, the market seems to be consolidating around those unified, opinionated platforms. They're winning on operational simplicity and just faster time to value. They help teams focus on the business instead of spending all their time just wrangling tools, which is, that's critical when speed is everything.
But the drawback of a unified platform is always going to be vendor lock-in, right?
That's the friction point. It always is. And that's why open standards like Iceberg, Delta Lake, Apache Arrow are still absolutely crucial even within those closed systems. They give you the escape hatch. They ensure your data is portable, which mitigates that long-term risk.
Okay, so let's talk about one of those standards. Apache Iceberg v3 is getting a lot of buzz for deletion vectors and row lineage. But is it really ready for prime time for the average user?
That's the key caution here. The reality check on V3 is a bit nuanced. It's definitely the future, but right now it's only really production ready if you're running on engines like Spark or Flink. For most teams using Athena or Trino or Snowflake there's still some pretty big gaps in feature support.
So for most people, it's still a wait-and-watch situation. That's a really important piece of context that gets lost in the hype.
Indeed. And just one last tool I wanted to highlight because it solves a very specific headache. When you have a high-performance analytical database and a transactional one, you often get stuck rewriting queries constantly.
Oh yeah, a huge time sink.
The PG ClickHouse extension is a fantastic piece of tech here. It allows for near universal query pushdown. You can run your complex analytics queries on ClickHouse directly from PostgreSQL. It just eliminates all that costly rewriting.
That's a beautiful piece of plumbing. Okay, so let's try to synthesize all of this. What does this mean for you, the person listening, when you take this back to your business?
I think the core lesson from all this material is that every single layer of the data stack is under intense pressure. And it's because AI agents aren't just reporting on data anymore, they're acting on it. The whole architectural model has shifted. We've moved from static reports to enabling dynamic, context-aware, reliable action.
So the infrastructure you have now, the one that was built for simple dashboards, it just won't cut it in the agentic economy of 2026. You need new databases, new reliability models, new governance.
And that leads to a final, maybe provocative thought for you to take with you, especially if you're dealing with infrastructure budgets. When we look at AI spending, everyone focuses on raw performance tokens per second, GPU horsepower. But sustainable platform economics, they actually hinge way more on high utilization.
Utilization over raw power. How high are we talking?
The profitable zone seems to be between 60 and 85% utilization, especially for API models. This means that aggregation, abstraction, and hyper-tenancy often beat raw peak compute as the real drivers of cost effectiveness. You just can't afford to have expensive GPUs sitting idle.
So it leaves you with a question, right? Is your company optimizing for just raw compute power, or are you optimizing for the financial and technical efficiency you get from superior abstraction in this new age of inference? That feels like the real financial reckoning for 2026 infrastructure planning.
Something to definitely mull over as you plan your next data investment.
Absolutely. Thanks so much for joining us on this exploration of the future of the data stack. We'll catch you next time.
Spoken Tech for your ears.